evening, everybody. I am Alexander Fedorov. I am working in Permafrost Institute. My presentation is the climate topic is climate influence on agro landscape in permafrost zone. I try to at first I would like to introduce you with the landscape of the Yakutia. You see the tundra landscape in the Tixi area, and I show you a few slides with the landscape of Yakutia. In this slide, and you see one of the famous and permafrost landscape, Edemo landscape. Edemo landscape consists in the deposits and approximately 70–80% underground ice. And this phenomena of the Edema landscape, they occupy the landscape area only in the Arctic and subarctic areas. Next landscape is the northern sparse taiga. It's this photo I make in Imekon Plateau, and Imekon, I think, and you know, it is the coldest cold pole in northern hemisphere. And one of the famous landscape, it is alas, and in upper pattern you see the young alas, and you see the trees, cutting the trees in the bottom of the alas, and this alas and formed after the cutting of the taiga. And in the down part, and you see one of the biggest of alas Tungulu in central Yakutia. It is a diameter approximately 10 kilometers. Alas and formed when permafrost and degrade and thawing, and underground ice and thawing, and ground subside, and the depression change to the lake. And when it is in alas, if alas and froze formed bulgunyar. It's usually in the permafrost literature you can maybe, and you know, pingo. The term is pingo. Pingo is the frost formed after the frost having of the talik under the alas. Approximately third part of the Yakutia occupied by the mountains. It is one of the mountains and Muskaya, and we working in this area and study the glaciers. Of course, and in the mountains, and not so only the glaciers and the Alp and mountain deserts, and we have the taiga and sparse taiga and others. But if you want to introduce the landscape of the permafrost landscape in Yakutia, and you can see this map, permafrost landscape map, and this map and was compiled in Permafrost Institute and show approximately 140 permafrost landscape, and with the characteristic of the temperature, characteristic of the permafrost, active layer thickness, and underground ice content. And in the down pattern, you can see the address, and this map you can download from our website. Алло, слышно, да? Алло.
Да, все хорошо слышно. Отлично.
Okay. It is a fragment of the legend, and it is a V20. We have the 20 terrain type. It is a geological, stratigraphic, genetic complex as marine deposits, alluvial deposits, and others, and marine and outwash, alas, and you can see, you can find in the what type of the texture of the permafrost, and volumetric ice content, and cryogenic, what the cryogenic processes, and in this type of terrain, and where in vertical part, and you see the vegetation units in Arctic tundra, typical tundra, southern shrub tundra, and others, and in and you see the temperature, ground temperature of the permafrost, and active layer thickness in all units. And we have the in the map, and I said, and we have the 140 landscape units. What this map and making the in the GIS 10 and GIS, and we interpreted it, and so one of the interpretation is the you see the map of the ice-rich permafrost in Yakutia. What next, my block shows the climate change, and you know that the Yakutia, and we have in Yakutia we have the one of the biggest climate change in the last 50 years. In the what my colleague and Alexei Gorokhov compiled what this map and mean annual air temperature, and you see the two belts with the big warming, and Shelagonsk-Vilyuisk, Yakutsk, and Yakutsk, Ush-Moma, and Srednya Koloma River. And also you see the precipitation, the changing from 1966 to 2016. And in the southern part, and we have the increasing of the precipitation, and in tundra area and decreasing. What it is a spatial distribution of the main climate characteristic. It is interesting for my presentation the changing of the air temperature changes in the long term, and you see the trend, one of the biggest trend in the Siberia, and also I pointed your your attention to the shift, the climate shift, and climate until 1990s and changing. What we have the average temperature and approximately the -10 degree in Yakutsk, and after in 1990s we have the shift, big shift, approximately and 2 degree, and 2 degree, and our climate was changed. And also in 2010s, also the temperature was increased. And this condition has a big influence to the permafrost and landscape. And there are many, we have the maps and scheme of the permafrost evolution and permafrost prediction of evolution. And you see in 2100 year in Yakutsk will be the in boundary of the thawing of permafrost. What line Igarka, Yakutsk, Magadan, and it will be the boundary of the thawing of permafrost. No, of course, and we wait and the big changing in our landscape. I would like to introduce you how the change the ice complex Edema landscape today. It is I show what you see in really what is a photo of Edema, and we have the high ice content in the deposits, and agricultural landscape, and of course occupy what this territory. What you see the central Yakutia, what here is the Yakutsk, it is a big agricultural districts of the region of in central Yakutia, and occupied by the high ice content deposits. What Alas formed, and it is a exposure with the ice, underground ice, and it is a high centered polygon. They show it is an indicator of the existing of the underground ice. What you see the temperature, changing of the temperature of the soil temperature, ground temperature at 3.2 meter. And of course, and we have also the climate temperature shift, and this shift and the what in after the 1980s, what this shift correlated with the permafrost degradation in the agricultural landscape. Why we have the degradation of the permafrost, and what we have the shielding layer. Shielding layer occupy the layer between the active layer depths, and ice wedges, between the ice wedges and active layers thickness. And in the open area, in the agricultural landscape and grassland, and when we have the increasing of the temperature, the climate warming, the active layer thickness and reach the top of the ice wedges and call the degradation of the permafrost. And under the forest, and we have the buffer, and we named it shielding layer. This shielding layer they protect the ice wedge from the degradation. What you see yesterday, what your lecture has the Neustroeva Isa, what she's results, and more than 70% of the respondent and said and they has the basement subsidence at home. No, it is a very big data, very big problem for the Едома areas in Yakutia. And you show you what the degraded areas. It is a runway of Churapcha airport. It was a runway, what here. And now, of course, and this airport and destroyed. And also, we have not big areas and rural settlements, and you see what is the polygons. It's polygon in everywhere. The polygons. These polygons show the starting of degradation of permafrost, and people cannot find and good places, and they occupy what degraded areas. What you see in this slide and photo, and you see the arable land, and this area was used until 1990s. After the 1990s, and all approximately the 50% of the agricultural lands was degraded and changed to the badland and polygonal and badland. No, it is from statistic, and before, no, in 1990s, and we have the more than 100,000 hectare of the cultivation area in Sakha. Now we have only 40,000 hectare in Sakha. But not only the agricultural territories they degraded. They degraded after the attack of the Siberian silkworm. It is in Churapcha area, and after the attack, forests died, and we have also the development of the thermocars in this area. What you see, the black spot areas, the countered areas, it was the arable landscape, and now this landscape and changed to the Thermocars Lake. What in photo you can see, and the changing of the landscape. It is also the arable landscape. The changing and from 1993 to 2018, and 25 years change. Via the 5 year, we are taking the picture, and also it is a show the satellite image also the show how the change of the areas of the Thermocars Lake. Also, we have the monitoring what in these sites, and approximately what mean rate of subsidence on this depression and Thermocars depression is and from 13 to 18 centimeter. And in this graph, and you can see the change of the rate of the subsidence. It is a centimeter, approximately for approximately 25 years, and we have approximately the 2 2 and 3 meter subsidence, ground subsidence. Also, it is a change of the water balance, and approximately 25 and 30% on input part of the water balance. We come from the ground ice thawing, and you see the via the 5 year, via the 5 years, the change of the water volume and water area in our experimental sites. But it is I show here the ALAS deposits, ALAS distribution, and red is approximately from 10 to 19%, and green and yellow, it is a low, and what it is a distribution, shows the distribution of the ALASs. Also, we prepared the project of the permafrost protection law, and it is a law was passed by the Parliament of Yakutia, Sakha Parliament, in 2018. It is a law of protection articles and principles, criteriums, economic regulation, and others. Included also the permafrost monitoring, state and public control over the protection of permafrost. Thank you very much.
Thank you.